Good day, I am Jeremy B. Luminsa, one of the reporters of the Unit 3, The Cosmic Abundance of Elements. This is the continuation of the report of Miss Jacel Humawan. Okay, so in my part, I will be discussing the properties of common elements in Earth and the concept of geochemical cycles. So, what is elements? An element are the building blocks of all matters in the known universe. Okay, what is matter? So matter is anything that has mass and takes up space or volume. Matter is made up of small particles known as atoms. The states of matter. We have the solid, the liquid, and the gases. The solid, they have a definite shape and a definite volume, and all particles are very close together. As you can see in the pictures, you can see a space between the two, between the particles because they are very close together to the point na hindi ka na makakakita ng space. Well, the liquid have an indefinite shape and a definite volume. So, liquid is an opposite of the solid because the solid is the shape and the volume is definite, while the liquid only the volume is definite while the shape is indefinite. So particles are not very close together. As you can see in the pictures, there is a space between them. Although some of them are close, but they are not very close like the solid. Okay, so next the gases have an indefinite shape and an indefinite volume. So gases, they are the totally opposite of the solid because as you can see, the solid has a definite shape and definite volume while the gases indefinite shape and indefinite volume. And particles of gases are very far apart and they can move freely. As you can see in the pictures, they are far away from each other and they can move really because of course if you have space or if you are far from each other, of course you can move freely. Okay, so atom is the smallest unit of any elements. The number of protons, neutrons, and electrons each type of atom has is what gives each element its unique properties and determines how it will chemically interact with each other elements. So we have here 10 abundant elements in the Earth's crust. First, we have the oxygen, the 46.10%. The next with silicon with 27.72%. Then followed by aluminum with 8.10%. Next, we have iron with 5.8%. The calcium with 4.15%, the sodium with 2.36%, and the number 7 we have magnesium, the 2.33%, and the potassium with 2.9%, and followed by titanium with 0.565%, and lastly the hydrogen, which is the 0.14%. So this is the 10 abundant elements in Earth's crust. Okay, some of these essential elements are required in the large amount and serve as the major building blocks of life. These elements termed macronutrients. So macronutrients include carbon, hydrogen, and oxygen, and are the elements required in the greatest amount. Over 93% of plant and animal biomass is made of these three elements, which is the carbon, the hydrogen, and the oxygen. And other macronutrients include nitrogen, phosphorus, sorry for the wrong spelling, it is potassium, sulfur, calcium, iron, and magnesium. These are required by all forms of life, but in smaller amounts than carbon, hydrogen, and the oxygen. Okay, so next we have micronutrients or trace nutrients. They're only required in a very small amounts. They're also essential, but are only required in very small amounts. Um, they generate serves as cofactors or molecules that assist in chemical reactions. Among the micronutrients are copper, zinc, molybdenum, the boron, sodium, nickel, and the chloride. Okay, so under Earth's atmospheric conditions, many elements are found in a form that has an electric charge and are called ions. So what is ions? Ions, they are the electrically charged because they don't have an equal number of protons and electrons. So we have two types of ion, the anion and the cation. So an ion, an atom has more electrons than protons, and it will have an overall negative charge. So if an atom has more electrons than protons, it is obviously a negative charge. If if an atom has more protons than electrons, then giving it a positive charge, it is called cation. So an ion, uh, just always remember this, an ion is an opposite of cation is, and a cation is an opposite of an ion. So if an ion is, an atom has more electrons than protons, is a negative is a negative charge, then a cation, of course, a positively charged. Okay, so let's proceed to the geochemical cycle. Okay, so geochemical cycle is the pathway that chemical elements take in the surface and crust of the earth. The term geochemical tells us that geological and chemical factors are all included. The migration of heated and compressed chemical elements and compounds such as silicon, aluminum, and general alkali are metals through the mean of subduction and volcanism is known in the geological world as geological cycle. So geological cycle represent the movement of a particular form of matter through the living things and non-living things part of an ecosystem. So the geochemical cycle encompasses the natural separation and concentration of elements and heat-assisted recombination processes. Changes may not be apparent over a short term, such as with biochemical cycle, but over a long-term changes of great magnitude occur, including the evolution of continents and oceans. So we have three main cycle: the water cycle, the carbon cycle, and the nitrogen cycle. Pardon me, guys, for not for not giving further information about that three main cycles: the water cycle, carbon cycle, and nitrogen cycle. And yes, that's all the unit 3, which is the cosmic abundance of elements. Okay, so there's okay, thank you. That's the end of our report with my member, Jasal Humawan.